Okay, one last thing we're going to talk about here before we kind of wrap up the first part of this unit and get ready for a quiz is to talk about distance. Now we're going to be talking one-dimensional distance here for a little while as far as on the number line. And it's a straightforward concept. All you have to do is count. If I ask you what's the length of segment AC, which would essentially go from A to C, I'm just going to count. Okay? A is at -8, C is at 0. If I just start counting 1, 2, 3, 4, 5, 6, 7, 8, it is going to be 8 units from, they are 8 units from each other. 8 units. Okay? Distance is always positive. You're not going to have a negative distance. You cannot have a negative distance. Okay? How about BF? Well, BF, if I start at B, and I go all the way over here to F, if you count, starting at -6, you go up to 19, you count them, you're going to have a total of 1, 2, 3, 4, 5, 6 to get to 0. Another 9 is a total of 15. So if you're asked to do distance on a number line, just go ahead and count the number of units from one point to the next. Now it's going to be a little bit more difficult when we come down and we're on a grid and we can't just do a straight line counting. Okay, I can't count units from S to T here because I'm crossing over grid lines. Alright, if the segment was all on the same grid line, then I could count, but it's not, so I can't. So in this case, we use this thing called the distance formula, which you see listed here. You will be given the distance formula on a quiz or a test, so it's just a matter of you knowing how to use it. Alright? They gave us 2 points. S is the point -3, 2, and T is the point 6, 5. Now, each of these points are considered an X and a Y coordinate pair, ordered pair, but I can't call each of them X because, well, then X is either -3 or 6. I don't have any way to tell the difference between them. So one of the points you have to call X1, Y1. So that's like my first point. And then the other one we're going to call X2, Y2. That's like my second point. And now all I'm going to simply do is I'm going to take those 4 points and I'm going to substitute them in here. Now you may want to get in the habit of doing this. I like to put in my parentheses, put in my subtraction, square it, plus, put in my parentheses, my minus, square it, so that I don't forget any of those things. Because all that stuff stays regardless of what the 4 numbers are. Now I can just take the X1, Y1, X2, Y2 and put them in their appropriate places. My X2 is over here, and that's a 6. My X1 is over here, and that's a -3. Notice, the minus is already there, and I also have a negative in front of the 3. Okay, both of those signs are in there, and that's one of the benefits of putting the minus in before you even put the numbers in. My Y2 is a 5, and my Y1 is a 2. So I have this set up now. I'm going to do a little bit of simplifying here, and then I'm going to give you an idea of what I think you should do in the calculator. My idea is this. I'm going to go ahead, I'm going to bring down my square root sign. Anytime you have minus a negative next to each other, together those make a plus. So really this is 6 plus 3 squared. Okay, so 6 plus 3 is 9 squared. Bring down the plus. 5 minus 2 is 3 squared. Okay? I'm going to do this by hand, and then I'm going to go back and show you where I think is a good place to grab the calculator if you're planning to do that. 9 squared is 81. 3 squared is 9. After I square, then I can add these together. I get the square root of 90. Okay? Now, calculator-wise, if you go back to this step right here, you can put all that in the calculator if you wish, the way that you see it. Okay? So I'm going to grab my calculator here. I would not suggest using the square root, though. I would suggest putting all the stuff that's under the square root. So it would look like this. Open parentheses, 6 minus negative 3. And on your calculator, the minus and the negative are two different things. Close the parentheses, and then square it with the x squared button. Plus, open a parentheses, 5 minus, I believe it was 5 minus 2. Close the parentheses and square that. So notice I'm not putting the radical. And the reason I'm not putting the radical is because then it gets a little tricky with where the parentheses are supposed to go. It's easy to make an error. Press enter, and I get 90, which is what I had down here. So you could go from this step essentially to that step by putting the stuff under the into the calculator that's under the radical. Now I want exact answers here. You can grab your calculator, do the square root of 90, and it'll give you some decimal, 9 point something, 9.4, I don't know, something like that. But I don't like that. We are going to simplify the radical. Now, you may not remember this from Algebra 1, but you're about to remember it because we're going to go over it. I do this thing called a jailbreak, or a breakout session, so to speak. I'm going to do a factor tree with 90. I know 90 is 9 times 10. That's just what comes to mind for me. Other varieties would work as well. And I keep breaking this down until all of the numbers are prime. 3 times 3, this is 5 times 2. Now 3 and 3 and 5 and 2 are all prime. So really what I'm saying here is that the square root of 90 is the same thing as the square root of 3 times 3 times 5 times 2. Those are the same thing. They just look different. Now the simplifying part of this goes like this. Because this is an understood square root, you need 2 of the same number. I pair these up right here because I need 2 of the same. 1 breaks out, 1 gets knocked off in the attempt to break out. So I have a 3 that made it out in front of the radical. The 5 and the 2 can't break out because I need 2 of the same number. So I don't have 2 5s, I don't have 2 2s. They're stuck underneath. It's basically just 5 times 2. So a 10 is underneath there. 3 radical 10 is the simplified version of the square root of 90. That is the distance between those 2 points. That's the length of that line. This line has a length of 3 radical 10 units.